All right, folks, it's Bass Action back in action here. Last page of notes that are required for this unit or for this particular section. The next video on Kramer's rule is optional for my students, but I would strongly encourage you to look at it. It's pretty useful. What we're going to do on this page is we are now going to combine what we've done in the last two videos. We're going to combine how we know how to multiply matrices, how we know how to find inverses of a 2x2 matrix, and then we're going to use those skills to actually solve a system of equations. So up until now, you've either done it algebraically, like in your Algebra 1 or Algebra 2 classes, or you have done the row operations that we did a couple days ago. So this is going to be another technique. So a third technique to solve a system of two equations. So we're going to start with a system that, again, as I've mentioned it before, I know that you know how to solve this particular kind of a system without using matrices, but that doesn't mean that it's not a good thing for us to review. It's good to work with something that we're already familiar with. So what we're going to do, our first step in this process, is to write the matrix equation for this system of equations. So on the left-hand side, what we're going to do is we're going to write the coefficient matrix. Just kind of throwing in this vocabulary from a few days ago. So 8, -3, 5, and 2. And then we're going to actually write our variables in here, so x and y. On the right-hand side, we're just pulling this from the equation. We're going to put the constants on the other side, 50 and 8. So as we read through this is good for you to maybe pause this and read it and slow down and think about it, okay? What we want to do in order to solve this equation is that we need to isolate this x and y, okay? Just as you normally would in any type of solving situation. So in order to solve for x and y, these variables, we need to get rid of this whole coefficient matrix. And what we understood from the previous video is that if we multiply a matrix by its inverse, we will get the identity matrix, okay? So if we can look at this coefficient matrix and we can find its inverse, then we can continue our solving process. So that's actually what we're going to do here in step 2, is we're going to find our inverse. So remember, our first step in finding an inverse is to find the determinant. So I'm going to find my determinant. Remember, that's going to be the product of the diagonal from the top left to the bottom right, so 8 times 2, and minus the product of the other diagonal, so a -3 times 5. So what we really have here is a 16 plus a 15. In other words, our determinant is 31, okay? So if I want to find my inverse then, what I have to remember is I'm going to take the reciprocal of that determinant. So I'm going to do 1 over 31, and I'm going to multiply it by the modified matrix. So I'm going to reverse the first diagonal, so it's going to become a 2 and an 8. And I'm going to change the signs on the other diagonal, so -5 and a +3. Now I'm going to distribute that 1 over 31, as gross as it is, I'm going to distribute that. So I'm going to have 2 over 31, and I'm going to have 3 over 31. I'm going to have a -5 over 31, and 8 over 31. So looks bad, but remember the whole point is that it's going to help us get rid of our variables. All right, so let me slide this so we can look at step 3. So in our next step, again, I've broken this down so that you can kind of see what's happening, but I want you to think about it. If we take our inverse times our original coefficient matrix, and of course in right here, we'll have these variables. What we know is that the inverse times the coefficient matrix is going to give us the identity. So that's how we're going to get rid of that part and be left with just our variables. Of course, what we do to one side of the equation, we have to do to the other side of the equation. Now, you'll notice that on the other side of the equation, I have this set up specifically with the inverse in the front. Okay, so it's the inverse times those constants. Now, that order is really important. Now, I say it's really important. It's important because the multiplication won't be possible if you reverse it. But at the same time, if you accidentally write it the wrong way, you're going to quickly figure out that something's not working. So let's go ahead and plug these values in and start to see how this is going to work out. And you do have to be a little bit careful with your handwriting here because it's a little bit scrunchy. So I've got this 2 over 31, my 3 over 31, my negative 5 over 31, and my 8 over 31. Okay, and then I, of course, have my original coefficient matrix, so 8, negative 3, 5, and 2. Of course, I have my variables, x and y. And I don't really even have to worry about actually multiplying this out. I could if I wanted, but I'm going to feel confident in my inverse. And I know that when those multiply, that in the next step on the left-hand side, I'm just going to have my 1, 1, 0, and 0, and I'll still have my x and my y. Okay, because these are just going to be the variables. So let's take a look and see what happens on the right-hand side. So on that right-hand side, I still need that inverse again. So 2 over 31, my 3 over 31, negative 5 over 31, and 8 over 31. And my constants were 50 and 8. So now I'm going to go ahead and do that matrix multiplication. So this one's going to go a little bit faster for us because remember our original matrix is a 2 by 2 and our second matrix is a 2 by 1. So these matched just like we wanted, but that means that our resulting matrix is going to be a 2 by 1. So this is going to be really fast. We're just going to have our 2 rows and our 1 column. So what I'm going to do is I'm going to have my 2 over 31. I always like to write these out. So I have my 2 over 31 and my 3 over 31. And I can go ahead and write my negative 5 over 31 and my 8 over 31. Okay. Then what I'm going to do is I can go back and I can put my 50 and my 8 in here. So I'm going to have a 50 and I'm going to have an 8 and I'm going to add those two products and I'm going to have my 50 and I'm going to have my 8. I'm going to add those together. So now as I work through that arithmetic, I'm going to put my brackets around here. That might help us. So as I put my brackets here, if I'm just going to go through and do this multiplication. What I would end up with is 100 over 31 plus my 24 over 31 and my negative 250 over 31 plus my 64 over 31. Okay, slide this up a little bit for us. Okay, so now, if I add these together, my 100 over 31 plus my 24 over 31 already have common denominators. Adding those together, I actually just get a really nice answer of 4. And adding these together, already common denominators, I don't even have to worry about it. And reducing that down, I get a negative 6. So this right-hand side then becomes our solution. So we can say that x, y is 4, negative 6, or we can actually write it as its ordered pair, 4, negative 6. So that is how we are going to use our inverses to find our solutions.